All right, here we go. Unit 3 notes. Energetics or thermochemistry is normally what I call this unit. And so going to start to see that we're going to look at some things that are different, things that we have not learned in a previous chemistry course. And so just going to start by going through some of the objectives. And so measuring heat changes is the first thing we're looking at. And so we're going to spend a lot of time figuring out how much heat was given off in a reaction. So if I do the reaction in the lab, how much heat does it give off? Does it heat up the container it's in, or does it absorb energy and cool down the container it's in? So we spend a lot of time with heat. So basically, energy into a reaction and energy out of a reaction. So if you kind of look at your objectives there, understanding heat is a form of energy, talking about temperature and the movement of particles. And then we start to get down here to delta H. And so now delta H is a value that we will find. And so we'll do math and we will find delta H. And what that means is change in heat or change in energy. And we get some formulas. So right here, we get Q equals MC delta T. That's a very common formula for finding heat. And so we just kind of start to look at some of those things. And so we'll practice a lot of that stuff. Hess's law, always interesting. An entire curriculum piece 5.2 devoted to one formula. So Hess's law is a single thing, and we will work that and do actually quite a bit of practice on that one. So, all right, so let's slide down here. Bond enthalpies, again, we are looking at energy. We are looking at how much energy is associated with like a single bond, a double bond, a triple bond. And so we'll have to remember how to write out bonds and shapes. So those things are going to, that we looked at previously, are going to creep back up again. Okay, so bonds stuff we'll have to relearn a little bit. So a little bit of review. And then we get into entropy. So entropy is S, and that's how disordered things are. And then we get into G, which is Gibbs free energy, a very, very, very common chemistry formula. And basically, it's going to tell us if a reaction is likely to happen or not. So when you put chemicals together, that doesn't mean reactions automatically happen. Some do, some don't. And we're going to look at that, and we're going to give that a term. We're going to call that term right here spontaneity. So just, more vocabulary. There's the general guide. There's the homework. We do some graphing in this particular unit, and we do some graphing with the lab. And so we'll end up doing some graphing. I do have 3 quizzes. I don't know if we'll get to them all, but there are more checks in this particular unit. And then here we go, kind of into the notes. So I'm going to slide over here to the Jamboard so we can start filling this out. Now, once again, I don't know how you guys are going through your notes, but you need to take time to do this properly, to pause the video, to digest the material. Everything in the notes is designed to help you on the exam. So please, please, please do not take shortcuts when it comes to going through the problems, etc. Because this is exactly what I would do in class. It's just you're doing it via the video. All right, so let's make this a bit bigger so you can actually see it. And this is just the notes that you guys are filling out. So right here, principles of energy flow. We're going to be talking about energy. We're going to be talking about where does energy go? And is it going in? Is it going out? What is happening with energy? So I'm going to zoom in a little bit because we don't need it all that space because we're not really working a problem here. So first of all, when you think about energy, think about for chemistry, the most common type of energy is going to be um, um, heat energy, because we have like the Bunsen burner, the hot plate. So we're adding energy via some sort of heat source. And so um, energy is going to be measured in joules. And so a if you see a J, so this, or kJ, a kilojoule, then that's a big hint that we are dealing with something from this unit, right? So we're going to be dealing with something that the formulas from this unit make sense. So might want to note that this is an extremely common topic on the IB exam. And so you should be well prepared for this. And so when you're studying for the IB exam next year, this is a very important unit to come back to. So, okay, what is the most important type of energy in chemistry? We've talked about it before. That is going to be heat energy. So you have the Bunsen burner, right? So we use the Bunsen burner. We have hot plates. We have things that are designed to start chemical reactions. These are very common. And then think about when you have a reaction. So we have a firework, right? So we have firework, and the firework blows up and it gives off all kinds of fun colors. Well, that is heat energy that is being released. And so just think about the chemistry that you've done. A lot of times things are going to heat up when you put things together. They heat up. When you have a reaction, then it heats up. And so just kind of think about that a lot of what we do, we're already associating with heat. So, okay, so here we go. Definition. Thermochemistry. Thermochemistry is a lot of times what this unit is called, and thermochemistry just refers to heat going in or out during a reaction. And so we're talking about a very specific item, but heat flow or energy going in or out while we're doing our reaction. Okay, so we have a system. So what is a system? So a system is an area where you're doing the experiment, or it's an area where you're focusing your attention on. And so the system is going to be a specific, this is going to be a specific area. And this is going to be usually this is going to be where the experiment is taking place. And so that can be a cup, that could be a room, that could be a sealed metal container, that could be a cardboard box. It's wherever the experiment is happening. And that could be as big as like the planet, right? So if you're wanting to talk about things like climate change and really big time topics like that, well, then the system is really big, because you're looking at, okay, we are looking at the entire Earth. If you're wanting to talk about maybe a medical trial, the system might be the human body. In this class, we kind of keep the system contained. So that might be a beaker, that might be a calorimeter, something like that. And so a lot of times that's where we're doing our experiments, but it really can be anything. And so the system can be quite a few things. So we have two types of systems. We have open and we have closed. And so if you have an open system, so if we've got an open system, then that means that the world can interact. So an open system can exchange matter and energy with surroundings. So think about this. If you do not have a 100% sealed place where the world cannot get involved, then you don't have a closed system. You have an open system. So open means things can get in, can get out. So air can get in. Temperature can change. Things from the outside environment can get in. So if you want to look at my beaker up here, it's an open system because obviously things can get in through the top of the beaker, right? So then we have the other system, which is the closed system. And the closed system means that things from the environment cannot get in. So if you want a closed system, then you're going to have a container, and then that container is going to have to be sealed so that nothing can get in. So if you have particles trying to get in, they're just going to bounce off. And so that's the difference. This is very, very, very difficult to create in the chemistry classroom. And so we have a really hard time creating a closed system because we don't really have devices that we can seal. So like we don't have like metal cylinders or something where we can seal them up. And so that's really, really hard to do in the class. So surroundings. So the system is the specific area where the experiment is happening. So where we're focusing our attention. And the surroundings are going to be everything outside of the system. So it's everything outside of the system. So that's everything else. So everything outside of the system. And so like this is the entire universe. And so all kinds of things can be going on outside of the system. So, all right. For you guys, the system's half time is going to be like a coffee cup. So nothing super fancy here. So got two types of reactions, exothermic and endothermic. We spend a lot of time with these terms, and we do really need to know them, even though they are not difficult. So an exothermic system means that heat is going to be flowing out. And so heat is going to flow out of the system. Heat flows out of the system. Now, when heat is flowing out, you want to think about this. So if you have heat flowing out, what does that mean? Well, that means that the container is going to feel warm because the heat is coming out. So if we've got our system right here, so here's our system, and it is pushing heat out. So here comes the heat. Then that is going to feel warm. So chemical reactions that feel warm are going to have heat coming out. So see, the heat is coming out of my system, and we've got a little reaction going on in here. And this is in our little calorimeter, but the heat is coming out, so it's going to feel warm, or the temperature is going to be increasing. And so just write that over here, that the temp increases because that energy is coming out. Not a very good looking S. Okay, so